Hello, this video is about map coloring, constraint satisfaction problem, and today we are going to color the map of Canada. Our constraint for this constraint satisfaction problem is going to be that no two neighboring provinces of Canada should have the same color, and we will demonstrate that as we go through this video. So for the scope of this project, I have used a Jupyter notebook. I could have gone with the traditional Python IDLE, but importing and installing new packages in Python IDLE is a bit troublesome, and for Jupyter Notebook it is fairly easier to install packages like which we are going to use in this project. So we have used a couple of packages in this project, as you can see. For example, import random, which is used for making random choices in a list. Network X, you will see in the further section of this video that it is used to plot certain graphs. Matplotlib.pyplot is used, which is used in conjunction with Network X again for plotting. And then for the advanced section of this video, we use GeoPandas, which is again used for plotting a map. Let's move on with the map coloring problem. We first import random. So before I get into explaining my code, I would like to explain that for this project I am using the forward checking filtering. That is, the domains of each of the variables are pre-populated, and we start with reducing the domains of each and every variable until we have to make choices on reduced domains. And finally we come to a conclusion where every province has a unique color. That is, every variable has a unique value from that domain. So let's begin. So we declare a list of provinces which has Alberta, British Columbia, Manitoba, so on and so forth. Then we have neighbors, which is a list of tuples. So basically this is the neighbor of every province. For example, Alberta's neighbor is British Columbia. Alberta's neighbor is also Northwestern Territory, and British Columbia's neighbor is also Northwestern Territory, so on and so forth. Next, we initialize a dictionary which has items and items key and values. The keys being our provinces and the values being our pre-filled domains, which I had mentioned just earlier. So to start with, every province has all the colors in its domain. As the algorithm goes on, we are going to reduce these domains values so that they do not conflict each other, so that the neighbors do not conflict each other, and we are going to end up with the reduced domain. So the next step is that we initialize another empty dictionary and another empty list. The significance of this is going to be explained later on. So basically this, as the name suggests, province color mapping is going to be a province and its corresponding color, which is going to be unique, and it is going to be different from its neighbors. A color map is basically just the province color mapping without the provinces. It's just the colors. We'll see the use of this later. So now I initialize a for loop. A for loop in for this dictionary for x, y in Canada.items. So I make a random choice. So I come on to the first element, first key, which is Alberta, and I look into the value of this key called Alberta, and I make a random choice by using random.choice. and I store it in a variable y. So now, when I got this variable y, I start filling up. Now I have got a province and its corresponding color, which was randomly selected at the start. When I've got these, I will start filling up my province color mapping dictionary, which I initialized further over here, with Alberta as being my first key, and y being the randomly selected choice from the list of all of these. And since I am on that page, I also append the value of y to my color map, which was initially empty, which is not empty right now. Then, being in the first for loop, I initialize another for loop in neighbors, which says that for I in neighbors, if x is in I0, that means that if Alberta is in I0, in the 0th element of this first tuple, if Alberta is in the 0th element, which is there, I initialize another variable z and give it the value of the first element of that tuple, that is BC. To put it in other words, if, just have a look at this thing, if Alberta is in the 0th place of the first tuple, I initialize another variable z and give it the value of its neighbor, that is BC in our case. So z becomes BC. Just keep that in mind. These print statements were used for debugging purposes, so like you can uncomment this and run it. You'll see how it works in the background. If z is in Canada, so this is another obvious if statement. So our value of z was BC. So for BC in this dictionary in Canada, BC is in this dictionary Canada, I select this list, which I have in the items, and I give it to the reduce domain variable. Then I initiate a try and except. I will explain this later why I did that. I reduce the domain and remove the value of y from it. So the value of y was actually a color, for example this. So I go to BC, and I take this list, and I remove the value of this from this list. So what I end up with actually is this list for BC. So this is the reduced domain of BC. So what we're trying to do here is that after we do this, BC will never ever take the value of this, which was initially assigned to Alberta. In other words, Alberta and BC are never ever going to have the same color. And there's a bunch of print statements here. So this loop basically goes on and on and on. So I come back to this. I come back to this, not to this one. I come back to this loop. And then I check for another neighbor of Alberta, and that is Northwestern Territories. So I go to Northwestern Territories over here, and I take this list. And initially the value of Alberta was this one, and I remove the value of this one from Northwestern Territories as well. So what color Alberta had, British Columbia and Northwestern Territories will never ever have the same color, because they have been removed from their dictionary items. Yeah. So this loop goes on and on and on, and comes back over here, and then goes to the second one, that is BC. So in our case, BC had a reduced domain over here, which was all of these colors. So now BC is going to make a random choice from random.choice y over here, and it's going to make a random choice, or for example this one, and then we're going to check the neighbors of BC, which is going to be Northwestern Territories again. And then we're going to go to Northwestern Territories. This value had already been removed, and now this value will already be removed. So Northwestern Territories reduced domain will be this. I hope that made some sort of sense. So basically this